Happy Monday, everybody. Today I am going to be teaching you notes, lesson 4-4. We're going to be studying about scatter plots and lines of best fit. There are 3 learning objectives for today. One is we're going to be interpreting scatter plots. The second one is we're going to be identifying correlations between data sets. And the third one is we're going to be using lines of fit to model data. So the very first thing that we're going to do is we're going to look at the definition of scatter plots. So what is a scatter plot? If you think of the word scatter and plot, thinking about a bunch of dots that are scattered all over the place. And basically what it is it is a graph. So a scatter plot is a graph. What else is it? It shows a relationship between 2 data sets. It is also 2 data sets that can be graphed as ordered pairs. And I want you to remember that if I'm talking about ordered pairs, that I am talking about the coordinate plane. So these data sets are going to be graphed in the coordinate plane. Typically, we are going to see them graphed in quadrant number 1 because we are typically talking about real life situations when we're talking about scatter plots. We know that ordered pairs can be written in the format of x comma y comma, and those are the points that live on the coordinate plane. What else about a scatter plot is that they can help show trends in data. And in fact, scatter plots and lines of fit are used a lot in business to look at trends in business, trends in sales, trends in voting. So they are useful. So let's take a look at this first example, example A. We're going to be interpreting a scatter plot. In other words, we are going to be reading the scatter plot. So we're going to just answer the following questions. We've got this scatter plot that shows the amounts x in grams of sugar and the number y of calories in 10 smoothies. So again, we have 2 data sets. What are the 2 data sets? Amount x of sugar, so the grams of sugar, and the number of calories in 10 smoothies. So take a look at our graph right here. You can see that we've got the coordinate plane. You can see we have an x-axis and a y-axis. And along the x-axis, we have sugar in grams, and along the y-axis, we have calories. So again, I told you in my previous information that we are probably going to be using or looking at most of our data that sits in quadrant 1. So it's asking us to answer the following questions. How many calories are in smoothies that contain 56 grams of sugar? So I'm going to look along the grams of sugar line, and I'm going to look for where I get to 56. You see I've got 54 and 58, and I know that 56 sits right in the middle. So I'm going to follow that up, and I'm going to see that I've got 270 calories in 56 grams of sugar. So I'm going to go ahead and answer the next question. How many grams of sugar are in the smoothie that contains 320 calories? So now I'm going to look on the y-axis. I'm going to go up to 320 calories. I'm going to follow that line all the way over till I reach the dot, and then I'm going to come down and read that I've got 70 grams of sugar. So I'm going to make sure that I write 70 grams of sugar. And you got to be very careful with your units, making sure you answer the question correctly. So then it says, what tends to happen to the number of calories as the number of grams of sugar increases? So now we're looking for a trend in the data. So what's going on? So as I look at the number of sugar, or the grams of sugar, as I increase in the number of grams of sugar, what's going on with the calories? Well, you could see that the calories are going up. So therefore, the number of calories increases as the number of grams of sugar increases. That's a trend. So I've used the arrow pointing up as an increase. This is number, so I've just done a little bit of shorthand. So let's go ahead and look at the next page, on page 24. Sorry, I got the wrong page in front of me here. So here's page 24. What you're supposed to do is use the same graph. So use this graph right here, and you're supposed to answer this question, number 1 and number 2. So I'm going to ask you to do that later, just to make sure that we get through this video okay. So what I did was I went ahead and filled in the problem or the answers to the practice monitoring progress. And the answer is 260 calories for 51 grams and approximately or about 52 grams if I have 250 calories. So hopefully you were able to read that graph correctly. So what we're going to do is we're going to now turn our attention to identifying correlations between data sets. And what I'm going to ask you to do is draw 3 quick coordinate planes and just, again, sketch them out as 3 from quadrant number 1. So what we're going to be looking at is we're going to be looking at identifying correlations between data sets. So there are 3 things that we are going to be looking at. We're going to be looking at what is the trend of the data telling us. So I have 3 different scenarios. I have what is known as a positive correlation. I have a negative correlation. And I'll write the word correlation underneath here. And here's correlation. And the other one is no correlation. So let's see what those look like. Well, if we're talking about being on the coordinate plane, then a positive correlation is when my data has a line or a trend line that looks positive. So you could see that my data points here are pointing in this direction. It's moving upwards. So as x increases, y increases. So that's a positive correlation. So you can also look at this as a positive slope. That could help you. So thus, a negative correlation is when, if I'm thinking about slope, then I could say that my line is negative. So I've got a negative slope. And a negative correlation is as x increases, y decreases. So you can see the trend is going down. The last one is no correlation. So, in other words, points are just randomly, or your data points are randomly placed. So the points show no pattern. Amongst your data. So let's take a look at example B right here. So in example B, it's asking us to determine whether the data shows a positive, a negative, or no correlation. So I'm going to look at this first one, and I'm going to see that the dots or the data points are scattered all over the place. And I'm going to look at just what this says, person's age in years versus the number of vehicles owned. So the number of vehicles that you own does not depend on a person's age. So basically, there is no correlation between the two. So then we're going to look at this next example, temperature and coat sales at a store. Well, if I'm just looking at the average daily temperature, you can see as it's colder here and the temperature is going up. And then I'm looking at the coats sold per day. Well, if you think about when do you wear a coat? When it's cold outside. When do you think stores sell lots of coats? When it's cold outside. So as coats, the number of coats sold per day increases as it gets colder and decreases as the temperatures rise. So I can, in a sense, show that as what is happening, as X increases this way, Y is decreasing. Therefore, this is showing a negative correlation. It also, if you look at the picture, the graph is going down. So now let's go ahead and turn to the next page, on page 26. It's asking you now to make a scatter plot. And making a scatter plot, here is your data points. You are being given your X and your Y, so you know that this is Y and this is X. For both of these, this is Y and this is X. And you need to then, after you graph this data, you're supposed to tell me whether the data shows a positive, a negative, or no correlation. So there's a typo right there. So what I'm going to ask you to do is I am going to go back. You could pause the video now and do this, or you can keep listening to the video, because what I want to do is get to the next part, which is using lines of fit to model data, because that's important. So you could go back and make your scatter plots later on. So let's go ahead and look at this next section. And this next section is about using lines of fit. And what we are going to basically be doing is drawing a line over data. So this is what it looks like. So you've got data. Obviously, if you kind of look at that, when data shows a positive or negative correlation, you can model the trend in the data by using a line of fit. So if you think about what I did over here, in example B, I drew a line through this data. And it wasn't a perfect line because I didn't use a ruler. But if I would have tried to draw a line through as many of these points as possible. And with that, that is called a trend line. And obviously we know that this is a negative correlation. Well, we have enough information now in our tool belt that we could actually draw a line of fit, and from that line of fit we could actually get the slope and write an equation of that line. And that basically is going to give us a model that we could use to predict. So what do we do, or what are the steps to using a line of fit to model data? Well, the very first thing that we're going to do is we have to make a scatter plot. And you did this up here in your practice and monitoring progress. So after we make a scatter plot of the data, and I'm hoping that you write this down, you have to decide whether it can be modeled by a line. What that means is you're going to go back, and if the data points are scattered all over the place, you know that there's no trend in the data. You're also going to be looking to whether the line is going down or going up. So if you can model it with a line, then you're next going to draw a line that fits the data closely. what you want to do is that you want to be able to get as many of the points as possible on the line that you draw. After you do that, you're then going to write an equation using 2 points on the line. So what does that mean? You're going to take the 2 points, you're going to calculate the slope. We know how to do that. You're going to use the point-slope form. We know how to do that because if you have an x1 and a y1 and you have a slope, then you can write an equation of the line. All of these things we did in the first part of this chapter. So let's go ahead and take a look at this example. So we've got example C, which is we are now going to use and find a line of fit. So it's asking us in this table, the table shows us the weekly sales of a DVD and the number of weeks since it's released. So we're supposed to write an equation that models the DVD sales as a function of the number of weeks since it's released. And then what we're supposed to do is we're supposed to interpret the slope and the y-intercept. So what does that mean? It means, what does the slope and the y-intercept of the line mean? So what are we given? We're given data. We know that weeks are on the x-axis, and we know that sales in millions is on the y-axis. So what I'm going to do is I'm going to label my graph right here. I know that weeks go on the bottom. And I know that that's my x line. I also know that this is my y line, and the y line has to do with sales, and I'm going to write millions because that's what we're talking about. So now what I'm going to do is I'm going to count by ones along the bottom. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And I'm going to look at my sales figures up here. And I know that they're in millions, and I've got to go from 5 to 20 approximately. So if I count by twos, if this is 0, I'm going to go, this is 2 million, 4, 6, 8, 10. So I'm just counting by twos, 12, 14, 16, 18, 20, and 22. So I know that that means 2 million, 4 million, 6 million. So now what I'm going to do is I'm going to plot each of these ordered pairs. Remember that I go 1, 19, 2, 15, and so on and so forth. Because these are my x's, and each one of these is an ordered pair. So I'm going to go ahead and do that. So 1 and 19, so I'm going to go way up here to halfway between 18 and 20. Then I go 2 and 15, which is right there. 3 and 13, which is right here. 4 and 11. 5 and 10. Oh, I like when those points are right on the line. 6 and 8. Another point right on the line. That's always nice. 7 and 7. And 8 and 5. So the very first thing I'm going to notice is, look at that. That line is going down. And I could tell that it almost looks like a straight line. So now what I'm going to do is I'm going to take a ruler, and I am going to do my best to capture as many of these points as possible on the line. So I'm just going to draw a line right through there. You could see that I drew a line through. And so now I'm going to pick 2 points on that line. Well, I can pick any 2 points as long as the line is going through those points. So I'm going to pick ones that are relatively easy for me. I'm going to actually pick this one because that one goes right through the line, and this one. So what is the point there? The point there is 5, 10. And what is this point here? This point is 8, 5. And take a look. X1, Y1, X2, Y2. What can I do with that? I could easily calculate the slope, and I can get a line of a linear or a line, an equation of the line. Sorry, I'm having trouble talking there. All right, so let's find the slope first. So the very first thing that we're going to do is I'm going to take and find the slope. So I'm going to go y2, which is 5 minus 0 over x2, 8 minus 5. And I know 5 minus 0 is 5, and 8 minus 5 is 3. Therefore, I have a slope of 5 over 3. And let's just make sure. y2, 5 minus 1, and this is 8. And I'm going to take away 5. So x2 minus y2. So, but take a look. So I want to go back up here. I read this as 0, and it shouldn't have been. This is why I was kind of puzzled, because I couldn't figure out why I didn't have a negative slope, because my line is going down. And I realized that right here I wrote a 0, and it should be 10. So it's 5 minus 10. So I wrote 5 comma 10, but I didn't see the 1. I actually saw it as a 0. So go back up here and change this to 5 minus 10, which means now I'm at negative 5. And 8 minus 5 is 3, so I have a negative slope of 5 over 3. So now, I've got a little bit of work. I wish they would have, maybe if I would have picked 2 other points, I would have had a nice, easy slope to deal with. But I'm going to go ahead and deal with that. So I know that this is my M. So now I've got my 2 points, x1 and y1, and I'm going to use point slope. So remember that point slope is y minus y1, which is equal to m times x minus x1. So I'm going to go ahead and substitute just like we were doing the previous lessons of this chapter. So I'm going to go y minus 10 is equal to my slope of negative 5 over 3 times x minus, and what's my x1? It's 5. So just like I did previously, I have to do some math. So I'm going to do y minus 10 is equal to negative 5 over 3x. Now I'm going to multiply. Negative 5 times negative 5 is a positive 25 over 3. And now what do I have to do? I have to add 10 to both sides. And you're going to remember that I need to convert 10 into thirds, which means I'm just going to get a denominator of 3 and multiply that by 3. So 30 over 3. 30 over 3 gives me 10. So now I'm ready to go ahead. I'm going to add 10 to both sides, which gives me y is equal to negative 5 over 3x. And I've got 25 thirds plus 30 thirds, which gives me plus 55 over 3. And in this case, because we are actually working with a real-life situation, I'm going to go ahead and make this, well, I can leave it like that, but I'm going to turn that into a mixed number. So I know that 3 goes into 55, how many times? 18, because that's going to give me 54, so 18 and a third. So now my equation of the line is y is equal to negative 5 over 3x plus 18 and a third, or if you wanted to, you could have left it as 55 over 3. So take a look. What do I got? I have an equation of the line. What does this mean? Well, I've got a slope of negative 5 over 3. So that means what? That these sales are decreasing by about 1 2/3 million. Because if I, convert that, -5/3 is -1 2/3. So basically, when I'm interpreting this slope, I'm basically saying that this is a loss. I know it's a loss because it's a negative. So my sales are decreasing by approximately, it's not for sure, it's approximately 1 2/3 million every week. So that's how much it's going down on average. That's the trend. Okay, so it says now to interpret the y-intercept. Well, that means that what? Y-intercept up here. There's really no context to the y-intercept because this is when x is 0. So basically at 0 weeks, there are no sales. So there's no relationship. So at 0 weeks, there are no sales. So, therefore, the y-intercept has no context. To this problem. The biggest issue here that I want to stress to you is the fact that we were able to draw a line through data points. And I can tell you with all sincerity and honesty, if I would have picked these 2 points right here, I would have had a nice, easy slope to deal with, and it would have worked out to a slope of 2. But I didn't do that. I deliberately picked 2 difficult points on purpose. So again, when you do this next practice problem right here, you're going to want to make sure that you try to pick points that are relatively easy to work with, and that way it's going to make it a whole lot easier to interpret as well as to calculate. So in looking at problem number 5, the practice monitoring progress problem, you have got some data points right here, and what you need to do is I'd like to see you please graph those in this coordinate plane. They're kind of difficult. They're pretty large data points, but do your best and see what kind of a line you come up with. Whether you come up with a line that you can write an equation from, and then go in and interpret both the slope and the y-intercept, just like I did right here. So for tonight, for homework, what you need to do is there are 2 sheets of paper that the sub should give you. One is yellow and one is purple. So let me show you what those are right here. So the purple one, please just do this back page where you're interpreting and you're reading the scatter plot. In this, you're supposed to just look at whether you've got a positive, negative, or no correlation. And right here, what I'd like you to do is don't graph this. Just pick 2 points on this graph and write an equation. So again, this one you don't have to graph. I just want you to look at the data, pick 2 points, write an equation of the line, and then interpret what the slope and the y-intercept means. So that's on the purple sheet of paper. For the yellow sheet of paper, what you need to do is you need to answer these questions 1 and 2, read the coordinate plane, interpret your scatter plot right here by reading the information, and on the back page, just tell us whether you have a positive or negative correlation. So tonight's homework is due on Tuesday, and I will be back in the classroom on Tuesday. And then hopefully you have a good day. And if you have any questions, you can ask me tomorrow when